What if the next giant leap in space exploration wasn't just a flag or a footprint, but a sealed canister of alien soil? Right now, China is preparing to pull off what no space agency has ever done: launch a spacecraft to Mars, collect samples from beneath its red surface, and bring them back to Earth, all in one breathtaking mission. This isn't science fiction, it's Tianwen 3, and it's launching as early as 2028. While NASA and the European Space Agency are working on their own Mars sample return mission, China's taking a different path: faster, more compact, and fully autonomous. And here's the twist: this mission won't just grab a handful of dust. It'll drill up to 2 meters deep, fly a drone to collect samples from remote spots, and return with at least 500 grams of Martian material, enough to rewrite the history of life in our solar system. The lander will touch down on Mars, deploy a robotic arm, a 2-meter drill, and even a sampling drone that can fly out several hundred meters to collect regolith far from the landing site. But here's the kicker: China is doing it all in one continuous mission, while NASA and ESA are relying on a multi-phase, decade-long effort involving several launches. No other mission has attempted this kind of multi-mode sampling. In this episode, we'll unpack how China plans to pull off this audacious triple play, what makes Tianwen 3 so different. Not green men or Martian cities. Think microbial fossils, chemical signatures, or buried organics that could prove Mars was once habitable. And why this mission could reshape the future of planetary science. Ready? Let's dig into the red planet's biggest mystery yet. If ancient life ever existed on Mars, this is where it would hide, preserved beneath the red crust for billions of years. Let us start with the big picture. How does China plan to snatch rocks from Mars and bring them home? Every grain returned to Earth is a time capsule from a world that may have once been alive. These zones are geologically diverse, and with final site selection coming by the end of 2026, scientists are betting on a sweet spot for ancient bioclues. This tiny launcher will then blast off from the surface, rendezvous with the orbiter, and hand over the sample capsule. Tianwen 3 isn't one probe. It's a complex two-part mission involving an orbiter and a lander launched separately. Meanwhile, the orbiter will wait patiently in Mars orbit until the lander loads the precious Martian samples into a small rocket called the ascent vehicle. Payload proposals are being accepted from researchers worldwide, and the Chinese Academy of Sciences says that once primary analysis is complete, portions of the samples could be made available for international study. Sounds like a sci-fi heist? It kind of is. One rocket to land, one rocket to launch back. No pit stops. Just pure space precision. Every gram of Martian sample will go through rigorous sterilization checks, biohazard screening, and international review before any science begins. This is not just about safety. It's about preserving the purity of Mars for future explorers and avoiding any Earth-based contamination. And if everything goes right, the samples will return to Earth by around 2031. It's a reminder that exploration is still alive, that curiosity still drives our greatest inventions, and that the biggest discoveries may still be buried beneath Martian dust, waiting for the right hands to find them, and return to Earth with half a kilo of samples that could forever change how we understand life in the universe. So what's inside those 500 grams of Martian soil that's worth the trouble? Tianwen 3's biggest scientific goal is to look for signs of ancient life. Unlike previous missions that scraped the surface, China's deep drill can reach layers untouched by solar radiation. Life may not be visible from space, but it could be sleeping just 2 meters below the dust. The team has already shortlisted 19 candidate landing sites between 17 degrees and 30 degrees north latitude, regions once believed to contain lakes, rivers, or even shallow seas. Beyond the hunt for life, the mission will help us understand Mars geology, climate evolution, and magnetic field decay. And remember, unlike Mars rovers, Earth labs can analyze samples with far more powerful tools: ultra-sensitive spectrometers, electron microscopes, and biosignature sniffers. This is our best shot, maybe ever, at answering one of humanity's oldest questions: are we alone? Of course, bringing back extraterrestrial material raises another big issue: planetary protection. China is preparing a high-level containment facility to receive the returned capsule. One microscopic mistake could end the mission before it begins, so security is airtight, literally. And in a move that caught the global science community by surprise, China has openly invited international collaborators. That means labs from Europe, the U.S., and beyond could one day examine Tianwen 3's findings, even if they never launched a single spacecraft. While politics in space can get complicated, science still finds a way to unite. This makes Tianwen 3 not just a national milestone, but potentially a global leap forward in planetary science. Tianwen 3 isn't just another space mission. It's an audacious test of engineering, timing, and global scientific cooperation. In just one mission, China plans to travel to Mars, land, drill deeper than any rover before, launch back into space. If successful, Tianwen 3 will mark a turning point, not just for China's space ambitions, but for all of us. So here's the big question. Will the first evidence of alien life come not from NASA, not from ESA, but from a lab in Beijing?